Welcome to the DIY Honda Garage channel. DTC P0206 indicates a malfunction in the number 6 cylinder injector circuit. This code is part of the Powertrain Control Module, or PCM, diagnostic system, which monitors key components involved in the fuel injection process. The injector circuit is vital as it controls the fuel delivery to the number 6 cylinder, ensuring optimal engine performance. If there's a malfunction, the PCM triggers the DTC P0206 to alert the technician of the issue. The first step in addressing this code is to verify the problem, allowing for an accurate diagnosis of the underlying issues at play. It is crucial to follow the recommended troubleshooting steps to effectively identify and resolve the fault, thus restoring the vehicle to optimal operating conditions. The DTC P0206 indicates issues specifically within the number 6 cylinder injector circuit. This means that either the injector itself, its control relay, or related wiring and connectors are not functioning as designed. The number 6 cylinder injector is located within the engine's cylinder head and is responsible for delivering the precise amount of fuel to the combustion chamber at the right time. The injector relay, found in the underhood fuse box, provides the necessary power to the injector. The Powertrain Control Module, PCM, receives signals from various sensors and adjustments and controls the injector operation accordingly. If any component in this circuit fails, it can lead to improper fuel delivery, causing poor engine performance, misfires, or even engine stalling. There are several potential causes associated with DTC P0206, necessitating a detailed investigation. Open circuits in the wiring can prevent voltage from reaching the number 6 injector or its relay, which can leave the injector unable to operate. A faulty injector relay can lead to power interruptions, preventing the injector from functioning correctly. If the Powertrain Control Module, PCM, has defects, it may incorrectly assess injector operation and fail to send the necessary signals to activate the injectors. Additionally, poor connections due to corrosion or loose terminals at critical points in the circuit can disrupt signal flow, leading to a circuit malfunction. Identifying and rectifying these issues will be key to resolving the DTC P0206. Drivers may experience distinct symptoms indicative of the DTC P0206. An engine misfire could occur when the number 6 cylinder does not receive adequate fuel, resulting in incomplete combustion. This manifests as a noticeable reduction in engine power and performance. Frequent stalling or difficulty starting the engine may also be present, particularly if the injector does not operate correctly. A rough idle is another common symptom, where the vehicle vibrates or shakes while at rest due to inconsistent fuel delivery. Ultimately, these symptoms highlight the importance of addressing the DTC P0206 promptly to ensure reliability and performance. The first troubleshooting step involves verifying the issue by putting the vehicle in on mode, ensuring all electrical systems are active. You must clear the DTC using the Honda Diagnostics System HDS, a specialized scan tool that provides essential diagnostic information. Starting the engine is crucial since the next steps require checking for the presence of confirmed or pending DTCs. If the engine does not start with the keyless access system, keep cranking for 20 seconds. This offers additional time for the system to start if it was momentarily failing. Observe the results after attempting to start the engine, as it will inform the next phase of diagnosis. Once the engine is started, it is essential to check the results. If the engine successfully starts, proceed to step 11, which involves further diagnostics on the injector circuit. This step signifies that the initial conditions may not point directly to a systemic failure. Conversely, If the engine does not start, proceed to Step 3, indicating that there may be an underlying issue that needs addressing before further testing is performed. This clear division based on the engine start outcome is crucial for an efficient troubleshooting process. In Step 3, first turn the vehicle off into the lock mode to ensure safety before accessing internal components. After ensuring it's safe, remove the injector relay from the underhood fuse/relay box for further examination. Testing the injector relay is pivotal. If the relay is functioning correctly, it should allow power to flow and activate the injector. If the test reveals that the relay is not operating correctly, this could indicate that the relay needs replacement. By addressing this step, you either confirm the problem exists elsewhere or potentially resolve the DTC P0206. Step 4 involves turning the vehicle to the on mode while ensuring the injector relay remains disconnected. At this point, you'll measure the voltage between specified test points, the injector relay 4P socket number 3, and body ground. This action confirms whether battery voltage is present in the circuit. If there is battery voltage, it indicates that the power circuit is intact and functioning as expected. Thus, you can move forward to Step 5. Conversely, if no battery voltage is detected, it suggests an open condition exists in the IGP wire that needs repairing before proceeding with other tests. In this step, turn the vehicle to lock mode to ensure safety measures are in place. The next action involves measuring the voltage between test points, injector relay 4P socket number 1, and body ground, ensuring the vehicle remains off during this process. This test determines if there is battery voltage present in the +B INJ line. If battery voltage is absent, it signals an issue that requires attention. Specifically, an open in the wire has formed between the A12 fuse and the injector relay, necessitating repair. Should the voltage be present, you will proceed to Step 7 for further inspection of the circuit integrity. To effectively diagnose the DTC P0206, it is crucial to examine fuse number A12, which has a rating of 20A, located in the underhood fuse/relay box. Inspecting this fuse should reveal whether it is intact or has blown. If the fuse is functioning properly, then you'll need to repair any open in the +D INJ wire leading to the injector relay. However, if this fuse is blown, it's critical to repair both a short in the wire between the fuse and the injector relay and replace the fuse itself. This step aims to ensure that the power supply to the circuit is complete. In Step 7, switch the vehicle to the on mode once again, while the injector relay remains unplugged. You are to measure the voltage at the injector relay 4P socket number 3 and number 4. This operation determines if battery voltage is present for adequate relay function. If the measurement shows battery voltage, it confirms that the relay is normal and functioning well, allowing you to proceed to Step 9. Conversely, if no voltage is detected, you should continue to Step 8, indicating a possible fault in the INJ/RLY line or associated components. For Step 8, you must ensure that the vehicle is in lock mode. To begin with, jump the SCS line using the HDS and allow over a minute before proceeding. Disconnecting the PCM connector A, 51P, allows you to check for continuity between the injector relay 4P socket number 4 and the corresponding pin in the PCM connector A. This step is vital for assessing whether the INJ/RLY wire is operational. If continuity is present, it indicates there are no issues in that section, and you should examine common points of failure elsewhere, such as connections to the injector relay and control module. If the test reveals a lack of continuity, proceed with repairs on the INJ/RLY wire. Step 9 requires you to confirm that the vehicle is turned off while accessing critical wiring components. Disconnect the injector control module connector D, 4P, for a clear examination. You will connect terminals A and B together with a jumper wire, allowing for proper testing across injector relay 4P socket number 1 and socket number 2. Measure the voltage at the designated points to ensure correct operation. If there's any voltage detected, it indicates that the IN-J-RLY out IGEDU 1 wire has continuity. In the event voltage is absent, this indicates a fault in the wiring or connection that should be promptly repaired. Continuing with step 10, you will measure the voltage between specified test points within the circuit. This helps confirm if the IN-J-RLY out IGEDU 2 line is functioning properly. If voltage is present, it confirms the wiring is intact at this section, allowing you to advance to step 11. Conversely, if no voltage is measured, it indicates there is a fault in the IN-J-RLY out IGEDU 2 wire that requires immediate repair to ensure circuitry integrity. Focusing on these aspects assists in isolating the malfunction and preventing further complications. Step 11 requires that you carefully remove the jumper wire from the injector relay 4P socket before reinstalling the injector relay itself. If necessary, reconnect the injector control module connector D, 4P, to restore circuits and prepare for testing continuity. You will check continuity between the injector control module connector C and PCM connector B, establishing a path at the designated points. Continuity here is crucial because it provides insight into whether the IN-J-TI6 wire is functioning properly within the circuit. Should continuity be found, this implies no issues exist in that specific area, and you may advance to additional checks in succeeding steps. During step 12, you must disconnect the PCM connector C, 51P, as part of the diagnostic process. The goal here is to check for continuity between specified test points to identify the condition of the IN-J F3 line. It is essential to ensure the vehicle is off during this check. A confirmed continuity means the circuitry is intact. If continuity fails, that indicates an open in the IN-J F3 wire that should be promptly repaired. Accurate continuity checking is a fundamental component in diagnosing wiring integrity within the system. In step 13, disconnect the injector control module connector B, 6P, as you prepare to assess the wiring integrity. By checking continuity between designated test points, you're determining whether the IN-J HS6 line or another comparable line has a fault. It is crucial at this point to confirm whether there are any open circuits in the associated wiring. If continuity is affirmed, you'll move forward confidently. If discontinuity is noted, that necessitates repair work on the respective IN-J HS6 wire between the nozzle and control module. This step ensures that electrical signals can flow freely, facilitating optimal engine operation. Step 14 focuses on checking the number 6 cylinder injector 2P connector. Disconnect this connector to assess continuity between it and the injector control module. This forms part of the diagnostic process for identifying any possible breaks or failures within the IN-J HS6 line. If continuity is confirmed, this indicates that the wiring is functioning correctly in this segment, and you should continue to step 15. If no continuity is noted, it implies a break in the IN-J HS6 wire that needs to be repaired to restore proper injector circuit operation. In step 15, you will check the continuity of the IN-J-LS6 line, similar to previous checks. This requires measuring between specified test points, ensuring that the wiring connecting the number 6 cylinder injector to the injector control module is intact. If continuity is confirmed, it's essential to replace all injectors as a set due to the interconnected nature of fuel systems. If continuity fails, that indicates an open in the INJ-LS6 wire, necessitating corrective actions. This step elucidates the relationships within the fuel system and underscores the importance of comprehensive injection assessments. Step 16 involves turning the vehicle to on mode, ensuring circuits are engaged for testing purposes. You'll measure the voltage between designated points to confirm whether the INJ-TI6 line is shorted to power. If any voltage is detected, this indicates a short to power exists that must be repaired immediately. Conversely, if no voltage shows, you can confidently proceed to the next step while considering the possibility of other faults elsewhere in the circuit. Accurate short checks are essential to maintaining circuit integrity and ensuring effective fuel delivery. In Step 17, you will again measure voltage between required test points in the INJ-F3 line to investigate potential shorts to power. Ensure the vehicle remains in the on mode throughout this test to maintain circuit engagement. If voltage is detected at the test points, it points to a short that requires immediate remediation. Should no voltage be present, it indicates that the circuit for INJ-F3 is intact, and you can continue to the next step accordingly. Attention to such shorts prevents unnecessary damage and ensures the smooth operation of fuel injectors in the Honda Pilot. During Step 18, turn the vehicle off to prepare for troubleshooting at the number 6-cylinder injector 2P connector. Carefully disconnect this connector and ensure you measure voltage between specified points as you observe the functionality of the wiring. This test confirms the absence of shorts to power in this area. If voltage is identified, it indicates a short to power issue that requires immediate attention. Conversely, if no voltage is measured, you may move to the next step, suggesting that specific circuits are behaving normally while isolating problems methodically. In Step 19, measure the voltage at specified test points in the INJ-LS6 line to ascertain whether any shorts to power exist. If voltage is indicated, immediate intervention is necessary to repair any shorted connections appropriately. In contrast, if no voltage is detected, this suggests that the wiring is functioning as designed. Re-examine all related connectors in the context of the DTC P0206 issue to ensure they are secure and free from oxidation or corrosion. Maintaining integrity in the fuel injector circuit is critical for consistent and reliable vehicle performance. Step 20 requires you to ensure the vehicle is turned off and check the continuity within the INJ-TI6 line. This step is vital for confirming whether the wire has been compromised or shorted to ground. If continuity is present, that denotes the circuit operates as intended. However, a lack of continuity signifies a fault that must be repaired to restore function. The integrity of these lines is crucial in maintaining effective injector performance and voltage delivery. Accurate continuity checking assists in isolating issues within the wiring harness thoroughly. In Step 21, you must continue the methodical approach of checking for continuity within the INJ-F3 line. This requires the vehicle to be in the off mode, where you examine the line for any faults. If continuity is established, it's a strong indication that the wire is functioning normally. Conversely, should continuity be absent, there is a short to ground that would need to be repaired. Ensuring that each line operates correctly minimizes chances of system faults and enhances vehicle reliability. Thus, this diagnostic step is integral to resolving the DTC P0206. Step 22 shifts the focus back to the INJ-HS6 line for continuity checks. This process necessitates that the vehicle is in the off mode while you assess wiring integrity. If continuity is discovered, it reveals that the wiring system is operational. However, if it fails to be continuous, there likely exists a short to ground that would need attention. Assessing these lines using methodical checks ensures that errors are caught and corrected. This step further affirms the overall efficiency of the injector circuit associated with DTC P0206. In step 23, repeat the established pattern of assessing the INJ-LS6 line. Make sure the vehicle is turned off as you examine for continuity. Just as with earlier steps, a found continuity confirms the integrity of the wiring. Absence implies an issue that necessitates repair. This exacting method of continuity checks across all relevant lines is vital for ensuring that each component functions as it should. If any shorts are detected along the INJ-LS6 wire leading back to the injector control module, those should be repaired to restore function. Step 24 focuses on ensuring the vehicle is off while disconnecting critical connectors related to the number 2 cylinder injector. Turn the vehicle back on for measurement of voltage to detect shorts to power. Should voltage be found, it highlights a short circuit that requires urgent repairs. Absence of voltage indicates a well-functioning connection. This is the final diagnostic step to isolate potential short-circuit issues within the injector control module system. By methodically verifying each segment of the wiring and connections, you can ensure the integrity of the number 6 cylinder's fuel delivery system, effectively rectifying the DTC P0206. After completing all troubleshooting steps and repairs associated with DTC P0206, it is essential to clear the DTC from the system using the HDS. Follow this by performing a test drive of the vehicle to assess any changes in performance and to check for the reappearance of the DTC. During the test drive, monitor the engine's performance, ensuring smooth operations and consistent fuel delivery to the number 6 cylinder. This final verification confirms the effectiveness of repairs and allows for the assessment of the overall health of the vehicle. If the DTC reappears, further diagnostics will be required to ensure all issues were captured and resolved. Preventive maintenance is vital in avoiding similar issues like those identified with DTC P0206. Regular inspections of the wiring and connections associated with the fuel injector circuit can help to identify wear, corrosion, or damage before they lead to significant problems. Inspecting the condition of each injector ensures they are functioning correctly and receiving adequate power. Additionally, maintaining clean contacts on all connectors improves conductivity and reduces the likelihood of intermittent faults. This proactive approach can extend the working life of components while ensuring optimal vehicle performance over time. To summarize, DTC P0206 highlights a malfunction within the number 6 cylinder injector circuit, potentially leading to performance issues. Following a systematic verification process is essential for diagnosing and addressing the underlying problems effectively. Repairs and preventive measures can ensure that the injector circuit operates optimally and prevents future occurrences of similar faults. Attention to wiring integrity, connections, and injectors themselves plays a critical role in maintaining vehicle performance and avoiding costly repairs down the line. By adhering to these outlined steps, technicians can help ensure reliable engine operation. Please like and subscribe to the channel. See you next time.